Okay, so this is a quick test of just something I implemented in GLSL. You can see the let's see, this is the fog factor, which this is actually from a lightweight Java game library tutorial, but I had to make some modifications to it for it to work properly with my little engine. So this is basically what it inputs. If I go to the render object, you can see that it will put the render distance in, but the render distance is somewhere in here. Here it is. So you set the renderer's render distance. And so because the chunks are at render distance 20, I have to do a multiplication of 16 because that's the width of the chunk. So if we run a release here, you can see everything kind of fades in, and I know the screen it looks really tiny, but we'll full screen it, and this is going to take a second. I don't know why this happens with GLFW, but you can see that as it is farther away from you, it's less visible. And this really helps with giving the illusion that nothing is loading. It's just there, which I think is pretty neat. I'm not really sure on how to make this a two-dimensional because the Matrix 4 is it's just kind of hard to work with without doing a lot of complex calculations on it. I could probably extract the XYZ data and get the distance by removing the Y value, so that instead of this being like the farther you get away from it, just the two-dimensional version of it being foggy, basically. It's a bit hard to explain, just so this doesn't happen. Like, the farther you get away from the map, the less detailed it gets, basically. So you can see that that starts completely fading away. And now, because of 32-bit color space, you can kind of see how this color banding going on. Because this is not an HD, HDR, HD color, whatever it's called, where it has more than 32 bits of precision. But basically, just it kind of does what I wanted it to do, minus the Y calculation, which shouldn't be in there. Basically, it should fade only on the two-dimensional plane of X and Z, and not include Y, but this is one step closer to it, so you know, it is what it is. There's nothing I can really do about that yet. But I'm probably gonna mess more with the Mat 4 and GLSL and see if I can get it to do a 2D fog, because you can see it looks really, I mean, it looks really cool, but even like up close, you can see that like even like a chunk or two away, it starts fading out, and even within a chunk's distance, it will start to fade. You can see that even in your own chunk, if you're too far away, it will start fading out, but I mean, that's just kind of what it is. We can actually mess around with the density. Here it is. So let's see, density. We can divide that by 2.0, I guess. Let's see. So that becomes a lot stronger. And if we take this further, we could divide it by 15, and now this is going to be really hard to see. Actually, we should probably turn down the render distance so we don't lose where we are. Alright, so now this is going to be like, you literally cannot see what's going on in front of you. One of the fixes is to actually either multiply this by 2 or take the divisor and get less. You can see it still looks like we have the same problem here, but in reality what's happening is it's just because the render distance is low. So if we turn the render distance up, we'll have less of that problem. So you can see that we have more distance. Oh yeah, let me full screen it again. That always takes a second. I need to get either I need to switch to Gleam, which basically replaces GLFW in Rust, or I need to figure out how to make GLFW full screen while it's still windowed, because like when you're recording and stuff, doing the full screen, you have to recreate the whole window. You have to destroy the window, and then you have to reinitialize it. And even though the back end of the GL is still the same, and nothing really changes, it's still rendering, and that black screen doesn't show up for you. It shows up while you're recording in OBS, and I don't know why it has such a hard time hooking back into the window. But you can see a lot farther. You can get up a lot farther, and it creates a very. It reminds me almost of Oblivion. In Skyrim, kinda. Not Oblivion in Skyrim, Oblivion and Skyrim, but more of Oblivion because it kind of abused fog a little bit more. Or maybe I'm thinking too far ahead in the Elder Scrolls. So you see, that's why the fog is so thick, because you can see how we can now visibly see the edge going in and out. But if we change the divisor back to 2.0, which there's multiple things you can change here to get different effects. Like if we change it back to 1.0 and we change this back to 2.0, you get all kinds of different effects. But if we change this to 2.5, you'll notice that literally everything is foggy, and it just becomes like a mess, basically. It's hard to see on the smaller screen unless you're watching on a PC. Here, I'll show you. Basically, literally everything is now foggy. And so this is more of like a real simulation, like everything is super foggy. Now, if we change this back to 2.0 and we change this over to 0.5, I thought this was kind of interesting. This kind of simulates like a super foggy day. Like maybe in the game, if I have like fog in the weather system available, you could probably activate this. I'll probably have to make this a uniform in the shader program, but it gives a really nice effect to be like, oh, you can barely see in front of your own face. Never mind, see into the distance. But if we actually combine this with the render distance times 2.0, you'll see that it has. Oop, hang on, I think I need to change this back to 1.0. Nope, see, this is where it gets complicated, because now that you change the divisor from the density rating, everything kind of gets messed up. So I think I'm gonna have to like. So if this is taller, so this times 4. Now you see. Oh no, math is so difficult. I got it. Oh, here we go. There it is. Okay, so the divisor has to be. Yeah, 1 second. The divisor has to be taller, and the. I think I've been saying this backwards the whole time. This has to be taller. This has to be shorter. But you can see that now it's super duper, like ultra foggy. Like you can't even see into the distance. It's like you're like inside of a cloud right now. It looks really cool. I think at least. If we change the background color, I have this wrapped up somewhere. It's in the render. Ah, there it is. So right here, if we, whoops, I'm doing like all kinds of key combinations here. I'll keep that as a backup, and then we'll just go with floats here. 0.0, no, that's 1.0, 1.0, 1.0. That's the RGB value, and then the alpha, which in Windows this ignores the alpha for some reason. On Linux it doesn't. You can make your window translucent. It's kind of cool. So this is gonna look weird now. You'll see that the background. So you see the effect is actually has gone away because it's not fading into the background, it's fading into the color space. We have to actually go into the fragment shader. Here it is. So you can see that this is actually, if I move this right here, this is actually exactly the same as the clear color, which is the GL, hang on, I forget the name of it. Oh my goodness. It's the buffer bit. Yeah, so it's color buffer bit, which is some GL magic that's hidden behind. In Vulkan, you know exactly what it is. You basically define it, but in GL, it's just, it is what it is. It exists. So this is a vector 3, so I don't have to implement alpha. And this is RGB 0 to 1.0. Anything above 1.0 causes some strange effects. But you can see, oh my goodness, it's so foggy out. And I think this better illustrates fog versus the blue sky clear color, because the previous colors that we were looking at where it was a blue clear color, that is for the like clear day kind of thing, but this would be more of fog. But I'm gonna pause the video for 1 second because I'm gonna look up a nice fog color. Okay, so I found my my fog color. It was from htmlcsscolor.com, and this color is called Scarpa Flow, but it looks like a dark fog. So HTML's original thing is 0 to 255 because it's an unsigned 8-bit integer, I think. Yeah, signed is negative, unsigned positive, whatever. So this divided by 255 will give you your value, but we have to also convert that to a float. And so because that maxes out at 255, that's how we get our 0 to 1 scalar, which is neat. I think it's really cool that we can do that. I'll probably make that a helper function so you can implement it, because we could do 113 as F32, which would just make it 113.0. But because this is just a video that's being made right now, we'll just do it as it is. It's not a big deal. Alright, so that was a tab. Let's remove these tabs out of here. Okay, now we have our actual color. And now we can just kind of plop them in. So I'll make another duplicate of this. And now we can just take this and just drop into this. I probably need to set this, you know, let's do that right now actually. Vec3 color, we'll say the fog color is equal to a vector 3 of that. And I messed up this spacing here, there we go. And so we could just say the fog color. And now this will look kind of weird. Yeah, that looks really weird. A little bit darker than I thought, but you know, it is what it is, I guess. So now let's go back into our renderer. And because this was a test, we don't have to do anything with that. We can just plop that in. And so you see, oh my goodness, it's very foggy today. And I think it looks pretty cool. It's a little bit darker than I thought. That's my bad. But I thought it would look cooler like that. I should have just gone with the original fog for a better implementation or representation of what fog looks like, so. Yeah, it looks pretty neat. I guess this would be useful for when it's really stormy out or something. So like all of a sudden the sky becomes this color and then bada bing bang boom, it starts raining out. I don't know. We'll see. Someone recommended to do a thing, and I'll do it right now. They recommended to do a different color per face, so we're just gonna do that now in this video, and I need to reset these values so everything isn't messed up. So what's like, okay, so I actually pushed these changes where it was this is the same, but this is its own vector because I can intake a uniform of the fog color and push it to the fragment shader. So I thought that was pretty cool. But we're gonna go to the thing because this is still in debug. It's in the game debug module. But we can just do this and we can go into the full screen mode. So, oh yeah, I could just press F11. I forget about that, but so we have this color, right? So this is the actual chunk mesh creation, and then basically we're optimizing our mesh here. We're doing a dry run and we're checking the neighbors, which we get the neighbors at, which is an optional reference. And then if it exists, then we can check if we can render a face. If the neighbor doesn't exist on any border, no faces get generated because you're not going to see those faces anyways. Let's see, what else do we get here? What else do we get? So this is after the dry run, and so this creates the vector with the float count, and then blah blah blah, the indices. But that's getting besides the point. Then we have to add the block. So we have our light here, right? And then so our light exists as 1.0 to 0, and let's see, where does light get implemented? Let's see, light equals F32 of 1.0. So what we're gonna do is 0 to 1.0, right? So we'll do 0, we do 16.0 divided by 16.0, which is 1.0. So that's our basis. This should give us just 1. And that fog is really thick. Oh my goodness. Everything looks the same, which is perfect. So now in our boilerplate, which I call this boilerplate because this file used to be like 3,000 lines long. It was really not optimized at all, but that's all right. So right in our Y face is up and our Y face is down, so this will be 1. And so what we'll do to add depth to the landscape is we're gonna subtract this by 0.5 divided by 16.0, and because of the fact that this is boilerplate basically, we'll do let side face light subtraction equal, and we need to do that 0.5 divided by 16, and this might be the wrong calculation, but we'll see. We'll debug that in a minute. So minus side face, blah, blah, blah. And oh no, oh there we go. Okay, so this blends in. Okay, alright, no, I see this. So that's actually quite noticeable. So if we actually, let's do something like really severe. Whoops, I forgot to add in my precision. Like something really severe. And this doesn't, like what is happening with this? Okay, yeah, that is serious. Okay, that adds in quite a lot of depth into the environment. You can see it, how lifeless this looks, and you look over here, and wow, all of a sudden it has depth. But that is too much. We only want to do a half step, maybe even like a quarter step. So you can see that adds in quite a bit. Now, what happens if we do the same boilerplate to just everything else? Z minus, and then X plus, and X minus. Let's find out. So very interesting. So this actually, and let me full screen this so you guys can actually see it. So this actually does add a lot of depth into the terrain. You can very noticeably, like just by looking at it quickly at a glance, understand what has depth and what doesn't. So I'm gonna try something real quick. So we're in this, right? And now I'm gonna pause it. Oh. Okay, this isn't working. Oh my goodness. It's not working. Okay. Yeah, so I think I actually forgot one of them. Oh no. Did I forget them? No, I didn't. It's really subtle. But maybe I'm not seeing it like you guys can see it because of the pause. Oh yeah, no, there's definitely a difference. It's so subtle, but it really makes the environment pop. It is definitely really interesting. I really like that. This is also with a mono texture. There is no atlas. I have to do the thing where I sit there for like 6 hours and I'm just like, why does this work? And then fight the borrow checker. Hopefully not too much though. And then create an atlas, but I gotta rewrite a lot of this code because this code is it's like prototyping code. Like I'll show you in a second, but anyways, somebody wanted me to do this, and I think it was Parker, and there you go, Parker. Hopefully this is kind of what you were wanting. More depth into the environment. It's really hard to do with this texture because this texture is designed to be noise basically, and it's you can see how much it repeats. You can very clearly see the loop in it. It's it just kind of is what it is, you know. But the main thing is when you're far away from it, it definitely shows up. It's like easy to tell what the environment is. It's kind of cool actually. I like that. It's pretty nice. And even as it fades out, what I'm noticing now is even as it fades out, it's it still has depth. So I'm definitely going to keep this in here. This is really nice, especially for the this is the main draw type. This would be like in Mind Test, this is normal draw type, I think, where it's optimized, like it's a full block, and then it can optimize faces. I'm gonna try to do some hybrid optimizations. What I mean by that is like for like node boxes in Mind Test, it draws every face, even if it's equal to 0.5 and it's facing down into a regular or a normal draw type, where it could obviously not have to render those faces or even include those into the draw type thing, the mesh. It still does, and I think there's some definite possibilities to save a lot of data that's getting sent to the GPU and save a lot of the workflow that the GPU has to render, because it doesn't, I mean, it doesn't have to do it. It shouldn't have to do it, but that's way down the line. That's way down the line, but one step at a time. Hopefully you guys enjoyed this like off-the-cuff video where I'm just kind of like showing off some stuff and programming some stuff and blah blah blah. So anyways, hopefully you enjoyed this video, and I'll see you in the next one. So I'll try to make this a smooth transition here. Oh no, this isn't working.